All right, all you algebra fanatics, we are back here, and now we're just taking what we've been doing lately, and we're going to use it to help us solve equations. I mean, that's what you run into in math, right? Is solving more and more complicated equations, and you need to keep adding things to the toolbox to help you solve this kind or that kind. So let's take a look and see how it's similar to things we've already done. For example, this warm-up here, x squared minus 16x equals 36. The major way we've learned to solve nonlinear equations, meaning it's got an exponent bigger than 1 as the degree, is to try to solve this by factoring. And so that's what we're going to try to do here. So we're going to bring this all over to one side, meaning we're going to subtract 36. And so we're going to have x squared minus 16x minus 36 equals 0. And of course, it should be noted that even if this doesn't factor, or even if you don't want to factor it or you forget how to factor, you could use the quadratic formula on any degree 2 polynomial, as long as it's equal to 0, you know? So you could do negative b plus or minus square root of b squared minus 4ac all over 2a. I like to try to factor first, though. It's x squared. So this wouldn't really require the AC method unless you wanted to use it. But me, I always try to go x and x and just look for two numbers that multiply to negative 36, add up to negative 16. That would be negative 18 and positive 2. And then set each equal to 0. And of course, when you set these equal to 0, you get the answers x equals 18 and x equals negative 2. There are your two solutions. Very nice. Okay, so just a little review of that. I haven't done some factoring in a while. And we definitely saw this too. If we approach this from the same way, hey, let me subtract 36 from each side. I'll have x squared minus 36 equals 0. There's no linear term, you know, there's no x term in this case, the middle, the b, if you will. So this factoring, it still does factor. You could factor this as a difference of two squares, xx plus 6 minus 6, the square root of 36, right? And then when you set each of those equal to 0, you get negative 6, positive 6. Or as some people like to write, plus or minus 6, if that's a little, you know, simpler for you to write that. But just keep in mind here, since we've been doing Pythagorean theorems, simplifying square roots, things like that, we did talk about this, that, and this is what we're really going to use more today, is that if you didn't want to do this by factoring, if x squared equals 36, you're just trying to figure out what squares to give you 36. You could just take the square root of both sides. Now you can't use that in this kind of problem because it's got that x squared and the x term. But if you just have x squared equals a number, you could just take the square root. As long as you remember this, that there should be two solutions. So when you take the square root of both sides, you have to remember to put plus or minus in front of that square root. So plus or minus 6, of course, obviously we already know the answer, but just showing you how you could get there two different ways. And that's nice to keep in mind because that is pretty fast. A lot of people prefer that method, but just good to know. Now, solving each equation, now I'm mentioning doing it by taking square roots, and hopefully you realize that we really don't have any other options because you have this, it's already equal to 0. This does not factor. 32 is not a perfect square, so this does not factor in any way. And that's the problem with factoring, is that not everything factors. So I'm going to approach it the other way, that if I only have x squared and a number, I'm just going to isolate the x squared, meaning now I'm kind of doing the opposite approach where I want to move the numbers to the opposite side, and that way I can get it to be like this and just take the square root of both sides. So if x squared is 32, then x must be plus or minus, because there are still two solutions to this, remember? The positive and negative square root. 32, not a perfect square, obviously, otherwise it would have factored. 32, what does that reduce to? Depending on how you like to do it. Root 16, root 2. The square root of 16 is 4. So we have x is equal to plus or minus 4 root 2. And yes, those are the two solutions. You know, you can check that decimal if you like, and that decimal, if you square it and subtract 32, you'll get 0. Okay, So, pretty good, right? Not too bad. Just showing you basically variations on that, but keep in mind before you take the square root in all of these problems, the goal is to get to something like this, x squared equals the number. Then you can take the square root. And so in number 2, don't take the square root first, because if you take the square root, you'll have that 2 on the inside with the x, and we don't want that. You got to isolate that x squared term, so divide by that coefficient of 2. X squared equals 45, and then we'll take the square root, so x will equal plus or minus the square root of 45. 45, not a perfect square, so perfect square, 9 comes out of there, and the square root of 9 is 3, so we have plus or minus 3 root 5. There we go. I mean, this is some pretty advanced math stuff here that I think you guys are handling pretty well. Number 3, moving along here, adding a few more things to this, but just keep in mind, to do this by square roots, your goal is to get x squared by itself. So you might have to do a couple things. And just like solving equations, if you were solving for x, the first thing you would do is you would add 11 and then divide by 3. And that's the same idea here. So just, don't make any silly algebra mistakes, all the rules you've learned this year. So we get, when I add 11 to that, that will be 216. And now I'm going to divide each side by 3. Divide by 3, I will have x squared equals 3 goes into here, 72. And now I'm going to take the square root of that. And of course, the most common thing I think people forget is that plus or minus. So keep in mind, quadratics, degree 2, have 2 solutions. If you forget plus or minus, you're only giving me one of the solutions. That's half credit for just a simple mistake. So plus or minus root 72, 72 not a perfect square. We've definitely seen this. Don't go 9 and 8, because 8's just going to have to reduce more by 4. So go 36 and 2. Square root of 36 is 6. And there's your final answer. X is equal to plus or minus 6 root 2. Very nice, right? This is a piece of cake. Okay, so just a couple more examples of this, but trust me, it does get a little trickier, so I've got some more variations here. But nice, start normally, add 7 to both sides. We'll have 16x squared equals 28. Now, divide both sides by 16. And okay, here's where you're going to run into some things sometimes. That 16 doesn't go into 28 evenly. It's a fraction. No problem. Just take your time, use good algebra. What does it reduce to? 4 goes into there, 7. 4 goes into there, 4. So we have x squared equals 7/4. No problem here. So x is going to equal plus or minus the square root of 7/4. You same rule, just don't let the fraction bother you. Plus or minus the square root of the other side. Now, how do we handle doing that? That's what we've been working on. We break up that fraction into 2 separate square roots. Still plus or minus hanging out in front. And we deal with those square roots separately. Square root of 7, not a perfect square, doesn't reduce in any way, so we'll leave it as root 7. And the denominator, 4 is a perfect square. Square root of 4 is 2. There's our answer. X is equal to plus or minus root 7 over 2. And there we go. Again, you could check that, you could convert that to a decimal on your calculator, the positive and the negative version of that decimal, and you could plug that decimal in here, and if you square it, then multiply by 16, subtract 7, you should get 21. Or very close to 21 if you round the decimal. But okay, all right, let's see here, just a few more, because there's still some little, I've got a different twist in each problem here. We've been adding on to it a little bit, so that's the good thing. You can go back and watch these if you get stuck. But I'm going to start. This seems normal. Add 4. I'll have 3x squared equals 25. Divide both sides by 3. X squared is equal to 25/3. Okay. X squared equals 25/3. So x is going to be plus or minus the square root of 25/3. Plus or minus the square root of that whole side. Doesn't reduce. Break it up into 2 separate square roots. Remember, you can never leave a fraction inside of a radical. And now here we go. We have plus or minus 25 is a perfect square. We get 5. Root 3, however, is not. So we're left with root 3. Is that a good final answer? Hopefully you're shaking your head no, because we can never leave a radical in the denominator. So we're going to rationalize that denominator. Hopefully you remember this trick from just a couple days ago by multiplying by root 3 over root 3. So we're just putting together all the little ideas we've been learning here into one big problem. And when I do simplify this, it will be plus or minus. That's still out in front. That's no big deal. Root 3 times root 3 is root 9, but that becomes 3, remember? And 5 times root 3, 5 root 3. So your final answer, 5/3 doesn't reduce. There it is, plus or minus 5 root 3 over 3. So you can run into some kind of ugly-ish answers here. But if you've just calmed down and just go step by step, you use the algebra you've learned, no problem. How about this? We've got x squareds on both sides. We've got numbers on both sides. No problem. Remember, your goal is to isolate x squared before you take the square root. So get your x squareds together on one side and get your constants together on the other. So I'm gonna do this all in one step. We're fine with this, right? We're algebra pros by now. I'm going to subtract 5x squared. And in the same step, I'm going to subtract 7. So 11x squared minus 5x squared is 6x squared. 22 minus 7, 15. Divide by 6, divide by 6. X squared is equal to 15 sixths. It doesn't go in evenly, but it does reduce slightly. So I think it's always a good idea to reduce if you can. 3 goes into there, 5, 3 goes into there, 2. X squared equals 5 halves. So now x will be plus or minus the square root of 5 halves. And if you already see where this is going, you could have, I guess, started right off with, you know what, let me just start with the 2 separate radicals, because that's what I'm going to need. Neither one is a perfect square. Neither one reduces in any way. Can't leave a radical on the bottom. Got to rationalize. Root 2, root 2. And now, of course, x is equal to plus or minus root 2 times root 2, 2. Root 5 times root 2, those are both square roots, so I can multiply them together. Root 5 times root 2 is root 10. Cannot reduce in any way. Remember, 2 and that 10, that's a radical, that's a non-radical. They can't reduce. So there we go, plus or minus root 10 over 2. Okay, last couple problems here. And one more straightforward equation before we get to this graph. I always got to bring the graphs in a little bit here and there. And number 7 here seems pretty straightforward. Subtract 60 from each side. 2x squared equals negative 8. Divide both sides by 2. Divide both sides by 2. You have x squared is equal to negative 4. You might see where this is going. You might not. But plus or minus the square root of negative 4. Now, do not ignore that negative. Sometimes people just say, same thing as square root of 4. Square root of a negative number. Does anything times itself give you negative 4? Heck no. In fact, if you don't trust me, trust your calculator, right? You love those things. Square root of negative 4, it's a non-real answer. We've talked about this every once in a while. It's come up, and you're going to learn more about this in Algebra 2, what are called imaginary or complex numbers when you have square roots of negatives. But for right now, we are just saying, hey, there's no solution to this. There's no real solution is what we're really saying. So square root of a negative, and that came up sometimes when we were doing the quadratic formula, when you were doing the b squared minus 4ac on the inside of the square root. Occasionally you got a negative, and that meant there was no solution to the entire problem, or your graph never touched the x-axis. So yeah, that don't ignore that negative on the inside. That's an important thing. No solution. Okay. And now that just to refresh ourselves on some of these graph properties, it's always nice to bring this back, that this right here is the graph of f of x, or y, equals 16 minus 3x squared. Notice a few properties here. This is a parabola, and it is opening downward like a frown here, and that's because of that negative a value, the negative number in front of x squared. that makes it open downward. You might notice that this vertex, just for fun, is at 0, 16. That's right there. This is a vertex form, if you like. 0, 16, it's opening downward. That's also the y-intercept in this case. But what we're really asking for are the zeros of this function, the zeros or the x-intercepts, also called the roots sometimes. And the x-intercepts are right here, and it looks like they are a little bit bigger than 2, in between 2 and 3, and in between -2 and -3. So let's find them algebraically. How do you find the x-intercepts? Well, the y value is 0 when you're on the x-axis, so you put in 0 for y. So I'm setting this equal to 0. I mean, this is y. I don't care if you put the 0 over here or over here. Doesn't really matter. And now let's solve. Well, let's get our x squared by itself. Since the x squared has a negative in front, maybe I'll move that to the other side this time. But it doesn't really matter. Hopefully you know that with the game of algebra now. As long as you follow the rules, you're okay. And then I'll divide by 3. Divide by 3. And I have x squared is equal to 16/3. If I take the square root of that, x is equal to plus or minus the square root of 16/3. Fraction, break it up, plus or minus square root of 16 over square root of 3. Square root of 16, 16 is a perfect square. Square root of 16 is 4. Root 3 doesn't reduce, not a perfect square. Can we leave it? No, so we multiply by root 3 over root 3. We're rationalizing that denominator, and we get plus or minus 4 root 3 all over 3. Those are your x values. 4 root 3 over 3. See, those are not something you could get from factoring. You could, however, have gotten this from the quadratic formula. If you wanted to do, a, b, a is -3, b is 0 because there's no middle term, and c is 16, the constant. If you did the quadratic formula, you would get this. And now you know how to simplify the radical part of the quadratic formula. And if you like, if you just want a sense of how much is this, 4 times the square root of 3 and then divided by 3. That decimal is about 2.309, etc. So positive and negative 2.309, that's the value right there. That's about 2.3, and that's about negative 2.3. So now you know exactly how to find it. Pretty cool when you think about it, but definitely a lot of little places you can go wrong if your algebra is a little sloppy. So try to be good with that. Go step by step, go slowly. Remember plus or minus. You have any questions, you ask me for help, or you ask each other. But don't give up, hang in there, and we'll see you later, kids.